This is a video that'll just give you an overview of Chapter 3. There are individual publisher videos and to go into more detail for some of these concepts, and there is also a link to one of my colleagues' videos. But this will just give you a little overview of Chapter 3. The beginning of Chapter 3 is review because it basically, from about 3.1 to 3.3, covers the basics of graphing. So, if you don't remember the actual coordinate system, you may want to just spend a little extra time going through 3.1, 3.2. You have your x-axis, your y-axis, and any coordinate is always going to be an x comma y, right? So negative 2, 3 would be negative 2, and then positive 3 for the y. So there would be your point. Of course, you have quadrant 1 starts here. In quadrant 2, you have negative x's, but positive y's. And we have quadrant 3, where everything's negative, x and y values. And over here in quadrant 4, where your x's are positive and your y's are negative. Of course, here we have our origin. Throughout this chapter, we're going to focus on graphing lines along this coordinate system. Okay? When you graph an equation of any type, okay, that equation could very likely have an x-intercept. For every x-intercept, the y value is 0. So it's really easy to find x-intercepts. You have an equation, you just plug in y, 0 for y. And then, of course, you have a y-intercept. And then for every y-intercept, the x value has to equal 0. Again, you find y-intercepts by letting your x value equal 0. Every equation, as you learned, also has a slope. This particular one, as we move from left to right, notice it's going down. So this particular equation would have a negative slope. And of course, if I had a line that was moving upward, it doesn't matter where it is in the coordinate system, what quadrant it's in, if as you move from left to right, if your line moves up, it has a positive slope. And if you don't remember your formula for slope, again, that is also reviewed in 3.1 to 3.3. And that, of course, is slope is considered in words the change in the y value divided by the change in the x value. This is also known as rise over run. In more mathematical terms, we use delta, little triangle, delta y, over delta x. And of course, the equation you're familiar with. How do you get that change? Well, after selecting 2 points, you take y sub 2 minus y sub 1, and then subtract the x values, starting with, of course, the same value first. Keep it consistent over x sub 1. So again, this is not meant to teach you Chapter 3. This is just to give you a little overview of everything that's in there. If you remember a lot of this, you probably do not need to go back and watch the videos in 3.1 to 3.3. But if you're looking at what I'm doing right here and you're not sure, you don't remember it, then that's a key indicator to kind of go back and watch videos in a little more depth for 3.1 to 3.3 and do those review homework problems. As we progress through Chapter 3 over this next week, what you will really get into is the equation of a line. There are 3 forms of the equation of the line. There is what we call our standard form. Standard form has the x value first, plus or minus. I'm going to write plus, but it could be minus if the y value's coefficient's negative. Notice a couple things for standard form. The x is first, and the x coefficient, our x coefficient is that a value, is positive. So in other words, what does that mean real quick? Well, if you gave this 3x plus 4y equals 7 as standard form, that would not be correct. It wouldn't be correct because my x value is not positive. So how do you change a term in an equation? Well, simply make it positive, but that's fine because technically what we're doing is multiplying everything by -1. If you're going to do that, this plus 4y becomes minus 4y, and that positive 7 becomes -7. Now, that is considered standard form. The second form that you will spend some time with in this chapter is one that you should also be very familiar with, y equals mx plus b. Sorry, I forgot to write what it's called. This is, of course, let me write it out first, is our slope intercept form. Y equals mx plus b. In that slope intercept form, the y and the x, of course, remain y and x. They represent any value on the graph. This is your slope. And this is the y coordinate of the y intercept. Okay? Keep in mind, I'm not calling b the y-intercept. The y-intercept itself is a coordinate, 0, b. That is the y-intercept. So it is the y-coordinate of the y-intercept. And that is your slope. You can take any equation in standard form and actually rearrange it to look like y equals mx plus b just by doing some simple algebra and solving your equation for y. So what would that give me? I'm going to move the 3x over to the other side. That gives me negative 4y equals negative 3x minus 7. And then I'm going to divide everything out by negative 4. Notice I divided everything by negative 4, so the y was alone. Fix my negatives. 3, that's just 3/4. X and a negative over a negative is plus 7/4. So this particular graph is going to go through the 7/4, which is somewhere between 1 and 2, closer to 2 on the y-axis. If we were to graph it, it would be 1, 2, about right there, 7/4. And it has a slope of 3/4. So I would, if I came, let's see, I would go up 3 and over 4. Notice that would put me into my equation. So I'm going to do the opposite. I'm going to go down 3 and over 4 just to come up with some other points so I can draw this line. You always need at least 2 points to draw an equation of a line. Don't forget that. All right, number 3. The final one that you are going to learn in this chapter, which you may or may not be familiar with, is called the point slope. This is really important. Point slope form. So point slope form allows you to write an equation. If you know a point, you know a slope. And it looks like this: y sub 1, y minus y sub 1 equals m. As you progress in algebra, there are things you should start to notice. This point slope form is simply this equation without a fraction. In other words, if I take this, multiply both sides by x2 minus x1, I get x2 minus x times minus x1 times that. We're just rearranging our slope equation. For this particular equation, some things we need to pay attention to. The y sub 1, the ones with the subscripts, that is any point on the line. That's any point. Okay, so it's basically, and then of course m is slope. So it's basically saying if you know any point on your line, you can then use the slope to come up with the line, as long as you know a point. That is the bare minimum that is needed to write an equation. So again, this is not meant to teach you everything. This is kind of meant to give you an overview of the chapter. This is something you really want to pay attention to. The other information, of course, that you want to take a look at when dealing with slope, as you watch this chapter, please pay attention to vertical and horizontal lines. Sorry, I'm not the neatest when I write on these things. Okay? This is going to be important. Commit this to memory. Know this. Every single vertical line, that is a vertical line, okay, has what we call no slope, or we say slope is undefined. Okay, I look at it this way: you can't walk up and down a wall. That looks like a wall. There's no slope to it whatsoever. On the other hand, a horizontal line, no matter where it is on your graph, has a slope equal to the numerical value of 0. That is completely different from no slope. This has a numerical value and it's 0. And if you tried to apply the formula, here you would get a 0 in a denominator, which would make it undefined, and here you'd get a 0 in a numerator, which is equal to the value 0. You are going to use all of this information ultimately to take anything you are given and to put it into an equation. So the last piece of information that you want to pay attention to as you're going through this chapter, of course, parallel and perpendicular lines. Parallel lines have slopes that are the same. If M1 is the slope of the first line, M2 is the slope of the second line. If they're parallel, M1 equals M2. Perpendicular lines, on the other hand, have what we call opposite reciprocal slopes. All right. So if this is M1 and that's M2, M1 equals the negative reciprocal of M2. So if M1, for example, it's positive, so let's call it 3/2, M2 would have to be negative 2/3. Whereas in parallel lines, if M1 is 3/2, M2 is also 3/2, because they are the same. So again, please, this is the information you want to pay attention to through this unit. We're going to put applications around it. This is just a short overview video. Please take the time to work through the unit. Pay attention to certain things, especially your parallel perpendicular lines and the slopes of vertical and horizontal lines, and know all forms of the equation of a line. Good luck with the chapter. You have lots of resources. You have the videos that I have in Canvas from the publisher to go with each set. You've got practice problems. You also have a link to one of my colleagues' YouTube channels who's currently making individual. You might like them better than the publisher ones. I leave it up to you. You also have the weekly discussion post. Make sure, again, you post by Saturday night. Review it. You won't be able to see anyone else's post until you post. I give you 2 days to look over everyone else's answers. And basically the idea is, do you feel confident in your own, or do you think you made a mistake? Repost to your own post by Monday night if you want to make a correction. And they will be graded on Wednesdays. All right, there's chapter 3 overview.